Hello guys, and welcome back to our YouTube channel. In this video, we are going to solve a question under bijectivity and the inverse of functions. Okay, the question says f of x is equal to x on x plus 3, where x is not equal to minus 3, and it is said that the codomain is 1, so we are to show that f is bijective, that is A, and B says find the inverse of f. Okay, let's start with the A part. The A part, which is to show that f is bijective. Okay, first of all, to show that f is bijective, we need to show that f is both injective and surjective. So we need to show that f is both injective and surjective. Okay, so let's take the first part. Let's start with injective. To show that a function is injective, f of x1 should be equal to f of x2. So that is what we are to show for injective. So let's start. We have been given our f of x as x on x plus 3. So our f of x1 will simply be x1 on x1 plus 3. So here we are substituting x1 with x in our f of x function. So that's our f1, and our f of x2 will also be x2 on x2 plus 3. So we are just doing the same thing. So now we are going to equate them and see whether we are going to end up with x1 equal to x2. Okay, so let's start. We have x1 on x1 plus 3 equal to x2 on x2 plus 3. So here we are going to cross multiply. So we are going to have x1 into x2 plus 3 equal to x2 into x1 plus 3. Okay, at this point, we are going to open our bracket. We are going to simplify it. So from here, we are going to have x1, x2 plus 3x1 equal to x1, x2 plus 3x2. Okay, so now we can bring like terms together. So if we see x1 and x2 on our left hand side and x1 and x2 on our right hand side, they are both like terms, so we are going to bring it together. So if we send this one over the bracket, its sign will change to minus and it's going to cancel out. So let's see, we are going to have x1 x2 minus x1 x2 plus 3x1 equal to 3x2. Okay, so this 2 is going to give us 0. So we are going to be left with 3x1 equal to 3x2. Okay, so remember, we want to end up with x1 equal to x2. That is when we are going to know whether it is injective or not. So at this point, we are going to divide both sides by 3. So 3 will cancel out there. 3 will cancel out here. And finally, we are left with x1 equal to x2. So at this point, we can conclude that f of x is injective. But that is not all. We are not done with the first equation. With the first question, sorry. We are still to test for surjectivity. So we are now to determine whether f of x is surjective or not. Okay, for surjectivity, for a function to be surjective, the codomain of f should be equal to the domain of f inverse. And the domain of f inverse is the same as the range of f of x. So these two should be the same for a function to be surjective. Okay, so in the question, we're already given the codomain. The codomain we're given as 1. So now we are to look for the domain of F inverse to know whether it is surjective or not. So to look for the domain of F inverse, firstly, we don't know F inverse. So now let us find F inverse. Okay, so our function f of x is x on x plus 3. Okay, so to find the inverse of this function, we are going to say y is equal to f of x, and from there we are going to solve for x. Okay, so we are going to have y equal to x on x plus 3. So now we are going to solve for x in terms of y. So from here we will cross multiply. We will have x equal to xy plus 3y. Okay, so now we are going to bring like terms together. All the terms which have x, we are going to take it to one side, and those which do not have x, we will take it to the other side, because we are looking for x, we are solving for x. So we are going to send this one this way. So we will have x minus xy equal to 3y. Okay, so we cannot leave it at this point because this is not how they solve for x. So from here, we are going to factor out x. So if we factor out x, we will be left with 1 minus y. We'll be left with 1 minus y, which is equal to 3y. Okay, so we are going to divide both sides by 1 minus y. Okay, so from here we will be left with x equal to 3y on y minus 1 minus y, sorry. So now we are going to replace y with x everywhere. So at that point, we can just conclude that our F inverse of x is, so now we are going to replace x with every y here. So that is going to be 3x on 1 minus x. So that is our inverse of f. Okay, now we are going to look for the domain. Remember, our codomain should be equal to the domain of f inverse for the function to be surjective. So we have found the f inverse. So now we need to look for the domain of our f inverse. So the domain of this function of our f inverse is simply r to 1, or we can say x an element of r, and x should not be equal to 1. So these are the two ways in which we can write our domain. You can use any one in which you think is better. Okay, so we have concluded that our domain of f inverse is equal to 1, and our codomain of f is also equal to 1. So from here we can conclude that the function is surjective. Okay, so remember we were asked to show that f is bijective. So we have seen that f is injective. We have also seen that f is surjective. So we can conclude that f is bijective. Okay, so that is all for the A part. So let's go to the B part of the question. The B part says find the inverse of f. So our B is asking us to find the inverse of f. But remember, when we were testing for surjectivity of this function, we found the inverse of x. So from above, our inverse of f was 3x on 1 minus x. So we can just simply write that from above. From above, our f inverse of x was 3x on 1 minus x. So that is all for the b part. Okay, so remember to find the bijectivity of a function. To show whether a function is bijective or not, we need to show whether it is injective and surjective. Okay, so that's all for today, guys. Thanks for watching this video, and I'll see you guys in the next video.